Okay, so now I'm going to teach you trigonometric identities, a very interesting topic, but obviously it will be connected to what I've taught you up to this point. So trigonometric identities, let me just maybe start by indicating that an identity is a mathematical statement that is true for all values of the variables, excluding the values for which the statement is not defined. For now, you might not need to worry that much about that statement. It will make sense as we continue. But most importantly, I want you to be aware of two very important identities which we will now consider and then prove. So let's see. Let me just write it down there. You say a trigonometric identities. So what we are going to be looking at. So we've got what we call a quotient identity, where we say at all the times, I'm sure by now you know, tan of an angle will always be equals to sine of an angle that you divide it by cos of an angle. It will always be like that. I will definitely prove it to you just now. Most importantly, please be aware that if that angle is equals to 90 degrees, it doesn't apply. So that's what I meant when I was saying, so that means the angle must not be equals to 90 degrees. So that's what I meant when I said what is it? True for all values of the variables excluding the values for which the statement is not defined, which means if you put 90 degrees there and you punch tan 90, it will be undefined. But do not worry that much about all of this. It's just for me to explain what I meant by that statement. But all that you need to know is that tan of an angle will always be equals to that ratio. It will be given to you as tan, and you just need to convert it to that without having to worry about all of that. And then again, now let's talk about the square identities. The square identities is the one where we obviously square that sign which is being added to squaring that one. So we say sine squared theta plus cos squared theta. What am I doing now? It is supposed to be equals to 1. So all the time when you see sine squared theta being added to cos squared theta, just be aware that it is equals to 1. So I'm pretty much sure that you are interested to know how those identities are like that. So now let's try to prove it. Maybe let's prove that this ratio, it is indeed equals to that ratio. So let's start with the proof. Definitely as we continue, you are going to be doing some more of proving, and it is the same principle. So let's now see. So in terms of proving, sine, the ratio for sine, what is the ratio for sine? Sine, we know it is y over r. So that is being divided by x over r, being adjacent over that. So I've just done this part. And then we do know very well that in primary it ends up being where you change that sign. After you change it, then the r goes to the top and then the x goes to at the bottom, whereby this will cancel with that, and you end up having y over x. And we know that y over x, it is the ratio for tan of an angle. So can you see that we've just proven that indeed this thing being a that over a that, it ends up being that, which is the same as that. So that's how we easily prove it. Maybe let's say that was proof number 1. Let's now do proof number 2, where we prove that indeed sine squared, remember, if it is sine squared, then it means it is y over r squared that is being added to cos squared. Cos is x over r squared. We just need to try and prove that indeed this is equals to a 1. Not sure why this thing doesn't want to write. Y is equals to 1. So okay, now let's see. Looks like I'll use my finger to write because this thing doesn't want to write. So obviously mathematically we know that that squared, it will square that, it will also square that r, so that you plus it with the x will be squared, and again the r will be squared. So your LCD is r squared, and then you end up having what is it, that y squared plus x squared. I might have taken a shortcut because I assume that by now you know how to deal with the fractions. You can do it the same way I've taught you. Definitely you will get to that conclusion. But remember this thing, I think it is the same as theorem of Pythagoras, where they said for theorem of Pythagoras, x squared that you plus it with y squared, it is equals to r squared. So it doesn't matter if it is y squared plus x squared or x squared plus y squared, whichever one comes first, it doesn't matter. It's like you're saying 2 plus 3. It is still the same as 3 plus 2. And this one is equals to r squared. So that means at the top we have r squared divided by that r squared. What is r squared over r squared? They cancel out, you remain with 1. So that's why we say sine squared plus cos squared will always be equals to 1. That's what you needed to know before we can continue. So the last part that you need to be aware of is that number 1, you've just learned that actually under this topic, it's very much important to note or know that tan of an angle equals sine of an angle over cos of an angle. That is number 1. Then number 2, I'm sure you've just learned that indeed sine squared of an angle, when you plus it with cos squared of an angle, it will be equals to 1. So as a mathematician, you should therefore be able to deduct that if I take this cos to the other side, then it looks like sine squared of an angle will always be equals to 1 minus cos squared of an angle. The same even if you take this sine to the other side. On the left you remain with cos squared of an angle, which will be equals to 1 minus sine squared of an angle. This you should know as a mathematician, because you are going to be dealing with a lot of problems that includes or involve that. So what I'm going to do now is to take you through some examples, of which through these examples I'm hoping that you will fully understand that introduction that I've just done. So now let's see. Let's say I'm just going to do some examples there. Let me see if this thing can write now. Nope. Okay, it can. Examples. Okay, let's do some examples there. Maybe this one as example number 1, where we need to factorize. So that means in our examples we are going to factorize. So factorizing the following is what they want you to do. So let's maybe keep it simple. Let's keep it simple and say you are given 2 sine of an angle, which is multiplying cos of an angle where we minus cos of an angle. Okay, so what are you going to do there? It doesn't look much complicated, because when you factorize, you definitely need to take out something as a common factor if it exists. Yes, we do have that and that. Please, honorable member, do not overcomplicate this thing. It's very, very simple. Very, very simple. It's like you are having 2k and m minus m. That's what you are having, because the k represents the sine angle, m represents the cos angle, and then m again cos angle. So you can always think of the k method and say, I will do the k method or the whatever letter method, where it's like here you end up having m taken out. What you remain with? You remain with 2k minus 1, being that invisible one there. That's it. But in this case, you are dealing with the trig ratios. Then in the end, you will therefore say, not that, but you take out the cos of an angle as a common factor. Then you remain with 2 sine of an angle minus 1. That's it. Nothing complicated there, honorable member. Example number 2, maybe let's say you have 2 cos squared of an angle where we minus 3, let's say cos of an angle, maybe let's minus 2. Yes, let's do it that way, where we minus 2. Okay, then it's fine. What else? Let's see. It's fine. What else? Okay, again, I'm going to encourage you, honorable member, to say, think of the K method. You can say, you can even say applying the K method. So let's introduce the K method, just so that it's easy for you to interpret. Once you are good, you may not need the K method. So that means you will say let, not that, you will say let. So where we see cos of an angle, we will let that to be equals to k. So it means we are having 2k squared minus 3k minus 2. That's what you are having. You now have a quadratic equation whereby you can use your quadratic formula to factorize. I'm pretty much sure that by now you do know how to factorize. Assuming that you do not, I will say fraction negative b, what is our b in brackets is negative 3 plus or minus square root of b squared negative 3 squared minus 4a2c negative 2 over 2a2. It gives us a 2. So that means in one of the brackets we are going to have k minus 2, and then you go up, you change that sign, put a minus, it gives negative 1 over 2. So that means the 1 will be here and the 2 will be there, obviously with that k, and then here the sign is the opposite sign, just so that your final answer will end up being that negative 1 over 2 that you got on your calculator. So indeed, as you continue, let's see, it looks like you don't even need to continue, because it's not like you are solving whereby this is an equation. It's not an equation. This is how it has to end up. But remember, you used the K method, so that means you have to rewrite it as 2 cos of an angle that you plus it by 1, and then on the other side you have your cos of an angle minus 2. Then it ends up as that. I hope that part makes sense. So now maybe let's jump on to example number 3. Maybe with this example, let's say we are having sine squared of an angle where we minus, let's say 2 sine of an angle, maybe let's multiply it with cos of an angle, then maybe let's just add cos squared of an angle. So here we are definitely testing your understanding of the factorization from your lower grades. Definitely you can still apply the K method or introduce the K method, just so that it's easy for you to do and interpret. So how will the K method work in this case? The K, maybe not just K, the K and another letter, maybe let's say letter P, whereby we say assume. You need to clearly state it to say we assume, let's see, maybe let's assume sine of an angle to be the one being K, and then cos of an angle, we assume this one to be the one being P. And then from there, you can therefore say I'm actually having K squared minus 2kp plus P squared. Yes, this is basically what you are having, of which definitely in grade 8 or 9 you will definitely realize that actually I'm just having the same thing here. I'm just having the same. I'm having K where we minus P. And again, you are having K where you minus P. That's all that you are having. The moment you have a different letter squared, and in between you have those same letters repeating themselves, especially there where you are having to, just remember this way of factorization, because the moment you say this by that, and then it gives you that K squared, and you say that by that, gives you negative KP, and you say this by that, it gives you again negative KP, and you say that by that, it gives you positive P squared. Negative, it gives you negative 2 being KP. So now it took you back to that original thing that you are given. Because you're using the K method, you just need to remember that you said your K is sine. So that means you are having sine of an angle where you minus P is cos, being cos of an angle. Again, sine of an angle minus cos of an angle. That should be the end of it. So I'm just exposing you to this type of problems, even though in real life or in examinations you might not need to expect such problems. It could be some straightforward things that you need to work out, but I just want you to be exposed to all types of problems that you might encounter. So okay, now what about this one? It should be an easy one, straightforward, because the moment you have that squared over there and you have 1, think of it as the difference between 2 squares. Remember, the question says factorize. So you need to end up having a final answer where things are inside the brackets. Remember, 1 squared, it is the same as 1. That's why in this case I'm encouraging you to remember the difference between 2 squares. Even if you apply the K method, that means you will say that minusing K squared. That's after you indicated that we are going to assume cos of an angle to be equals to K. So when you see cos, you put K, you know the squared, it is actually there outside. Then now you can easily say the difference between 2 squares, you just write it exactly as it is. The only difference is that the signs on the other side, if it's a minus, the other side it is a plus. So now you are going back to your trigonometric things. Okay, this thing is on and off. And then again you will have 1, this side you'll have cos, then it is that cos of an angle. There it's a minus. So that's how you would work it out. So let's see if maybe this one can work out. Where's that electronic pen? Here it is. Okay. Okay, it's also on and off. I don't know why. I'll have to make blend, but it's fine. Okay, so that's how you would work it out, honorable member. I'm just curious to know if I need to do some more, or if this should be enough for today. I think this is enough for today, honorable member. I'm not sure. I'm just trying to think if indeed, yes, this should be enough for today. Yes, I think this should be enough for now or for today. Okay, I will leave it here and say until